Okay, great. So guys, welcome. Tonight we're going to be talking about the OWASP API Top 10, and we'll be walking through each one of these attacks with some examples and some reasons why we should all take note. Really appreciate everybody's attendance. It looks like a great group. Again, feel free to ask any questions as I go through the presentation as they come up. There's no need to wait to the end or anything like that. And feel free to to raise your hand if you need me to stop or if I'm missing something. So great, guys. So a little bit about myself. Adam Fisher. I've been in application security, I feel like, for as long as I can remember. I now locate in Utah. I've been out here since 2012 after a few stints living internationally and working abroad. And there was a time when I was on a plane, as you can see. My house was on a plane before, but no longer. This little thing called COVID came up, and I should actually change my basement to more like my dungeon. Back in April of 2020, I used to call it my basement, then it was my office, and now it's just my dungeon, but here I am again. But most likely, like so many of you, my real job is being a professional soccer parent, as that continues to take all my time. I'm actually missing a soccer practice tonight to be here with you guys, so consider yourself lucky. Appreciate that. Yes, I think it is possible to disable the join notification, which would be nice. Let me see how that is possible. I saw that before. Why don't I see that now? Here it is. Okay, gone. You should no longer hear the dinging noise of everybody else joining. Thanks for that, Norman. Okay, guys. Now I will say one thing. By a show of hands, how many know of WinNuke 95? We're going to judge the age of the audience if you can. I got one thumbs up. Okay, 3. That's impressive. 3 out of 48. Yeah, every time I ask this, it shows my age. So WinNuke 95, if you feel like rolling back the clock, was how I nearly got suspended from high school by basically DDoSing my computer science professor's computer during class, so he couldn't give his lesson, which was awesome. But it was a wonderful, wonderful intro. I'm so grateful for a very vulnerable operating system back in the day that helped me get into security and all the fun that it involved. And because of that, I like to say that's where I am now. So WinNuke 95, take a minute, look that up. Great tool. Okay, so let's start talking about APIs and we'll get right into it. Traditional web applications didn't involve really APIs, and I like to use the example here of eBay. And again, I'm probably rolling back the clock for some of you, but eBay back in the year 2020 created the very first API. And the reason they needed that is because they had an auctioning website. And as that auction would tick down, bit by bit by bit, people could obviously put in their bids and hope to, win the auction with the lowest amount possible. And usually in the last 60 seconds of an auction, all of these bids and the price would change rapidly, would come in very quickly. And they needed a way to convey that data quickly without requiring the entire rendering or the entire loading of the entire browser page. And so that's why for in eBay's case, they came up with an API that would retrieve just the specific amount of data that they needed to load that part of the web page, just the price as it was being updated. And of course, now we see the proliferation of APIs across all aspects of the internet, of our applications, where you're able now to run a web page on a lot more resources than just than just like in a browser. So now we have a mobile application, we have IoT devices. I like to use the Netflix example, where now Netflix is really the same application across multiple different devices. I can literally scroll infinitely, and all of my recommendations populate in the application. I'm not refreshing anything. I'm not requesting the entire application. I'm just requesting a small subset of the data that needs to be displayed on my screen. And this is kind of continuing how we see APIs evolve. In the security world, why we see this from a security perspective is now APIs are starting to traverse and access more sensitive data than they ever have before in the past. And so from my perspective as a application security professional, it's up to me to make sure my customers are securing that data and are able to now interact with their customers and do their business across APIs. So excellent. Now I want to gauge a little bit. If you are an API developer, raise your hand. Give me a thumbs up in there somewhere. Let me kind of gauge who I'm talking to tonight. If you develop APIs, all right, great. So we got a few out there. Okay, great. 4. If you are more responsible for securing applications in your environment, or more of a security engineer, raise your hand. Okay. All right, more. There we go. Now we're talking to my people. Okay. So anyway, yes, that's where I live. But great to know kind of where we're at here, so I can kind of speak to both aspects. So on the development side, the other thing that I see, especially with my customers, is the pace at which APIs are developed, are updated, new features are added to them is, much faster than what we might refer to now as legacy web applications. I have customers that have up to 42 API releases a week. So think of that, nearly 6 to 7 times a day, they're pushing out an update to an API application. And I think it's safe to say, in the traditional application sense, that's not possible to update a web application or just an application that often. And so that's also why APIs are here, just a lot easier to update and to move forward. Now, because of that inherent difference between what I would say is a traditional web app and now an API-based web application, is the difference in attacks that those applications face. Because of that, in 2019, so December of 2019, was when the API Security Top 10 was officially released. And this really set the groundwork to highlight the difference in how these applications, these new API applications, need to be secured and need to be protected. So my background was in web application firewalls for a number of years. And I quickly saw that as more and more of these API endpoints were added or just began to proliferate in my customers' environments, that we continue to have less visibility, and the features of the solutions that we provided only covered maybe 20% of what an API needed to really be secure. And there's lots of reasons for that. We'll get into some of those tonight. But I specifically want to highlight on the uniqueness of the attacks that APIs are now facing. We can see here the most common holdover from the traditional API top 10 is this injection, so the A8. This is something I'm sure we're very familiar with. It's not new, and that's why it's so far down on this list. When you look at a traditional security list, the injection attacks are basically broken out and cover nearly all of the top 10, but they can all be categorized as simply injection attacks, whether that is SQL injection, a cross-site script, local file inclusion, server-side requests, things like that. All of that is just combined into, hey, it's an injection attack when we talk about API security. And that just highlights, again, the uniqueness and the newness of the attacks APIs face. So great. Excellent. Now, let me say this. I kind of always highlight on this. Are there any specific attacks on here that maybe you are familiar with and you'd like me to spend a bit more time on, and maybe I talk a little bit in more depth on one of these? If there are anything, if there's an A1, A2, if there's anything you were hoping I really focus on during this time, please just drop a note in the chat window and I'll be sure to cover that perhaps in a bit more depth for you. Okay, great. So wonderful. So let's go in here and we'll take each one of these as we go. And I have a few real world examples. Some of these were easier to find real world examples than others, but nearly all the time now you're seeing these on nearly a daily basis. So the A1 is definitely an A1 for a reason. This involves truly extracting user data. So if you have an API that is vulnerable to a broken object level authorization, nearly guaranteed that you're going to start leaking data and that somebody's going to walk out the front door with not just a record, but probably a lot of records of users or information that they shouldn't. Now, what we have here is we're looking at a legitimate API request. And here we can kind of see the format of this request. We have here a get request with a query parameter for a user ID. And now this can be a request that anybody sends to the API endpoint. What's really important here is that we look at this from a cookie perspective, in that what I'm authenticated with is this user ID here. So I'm authenticated, I get a cookie that contains my user ID. And this doesn't have to be a user ID. It can be anything that authenticates me. This could be a token value, a specific just API key, if you will, as well. And I send this GET request and it returns the user information that belongs to that user ID. So for me, when I'm working with my customers, when I see an endpoint that contains this type of information, I immediately think, oh, I wonder what's available here. And so even when I'm authenticated, we look now at the request here that is malicious. I maintain my authentication. I still have that I'm authenticated with the correct cookie, with the correct token. But now I'm simply modifying the user ID in the query parameter to see what I can return. And the essence here of this broken object level authorization is that even with my credentials, I'm now able to return the user information or the records of somebody else that I'm not supposed to be able to return. Now, this is clearly like a data exfiltration attempt. This is just an easy example. The main concept here, though, is with a broken object level authorization, is I'm able to return the information of some aspect of the system that I'm not supposed to have access to. And so right away in this request and in this attack, we can see how it looks completely different than what we would think a traditional web application attack would look like. There is absolutely nothing malicious here that looks malicious, right? Do we see any type of, server code or scripting language that we're trying to execute on the API? We're not. All we've done is simply change the user ID parameter to a different user ID. And why this is so malicious is because if this works for one user ID, the attacker is going to think, oh, well, it's probably going to work for 045 and 046 and 047. So they can now begin to just enumerate the user ID values. So from a coding perspective, there's a couple of things you want to be careful of. One, like if I'm developing this API, I need to make sure I'm checking each request to verify not only is the user authenticated, but he's authorized to see the data that's being requested. And then two, the really big thing is we hear this a lot, is we don't want to have sequential user IDs. Like that's like classic no-no, right? It makes it super easy now for me to scroll through these user IDs and just return user data once I see this. So I see a question out there, how does this differ from IDOR? So IDOR stands for Indirect Object Reference, and it was what the A1 was called before the OWASP organization renamed it to Broken Object Level Authorization. To me, they're absolutely interchangeable. There's probably some lower level development differences, but from the OWASP top 10, you will see them referenced as IDOR or broken object level authorization. Just know that it's the same, and it's a great thing to be confused about because I hear customers use them interchangeably still all the time. I will be making this presentation available. There's nothing in here that I can't share. So I can include that. I can send it over to Travis after this is done as well. Okay, great. Now, so let's look at some examples of this. This is one of the more common ones. It's a little bit dated now, to be honest, because there's other examples that have come up, but it's still a great one. It just validates the need so much here. Basically, is exactly what happened here. A user is authenticated to a Verizon endpoint that allows them to return their basically their contract, their Verizon wireless contract, and with his authentication to return his contract, he realized that hey, I could just enumerate the contract IDs and return everybody else's contract information that obviously had, their address, personal information, all that stuff associated with it. And he was able to return up to 2 million Verizon wireless customers, all because all he had to do was change the contract ID. So there was nothing, I mean, think about this in the traditional web application world. This would have to be like a select star from contract table or something, and you have to like dump the database with all this information. Here in an API world, he literally, where it says user ID, this was contract ID, and he enumerated the contract IDs and walked out the front door with the data. Now this next one is absolutely just ludicrous. I remember when this one happened. I mean, this was going back a little bit further, but this was back when the United States Postal Service released their, track your mail application. And very easily here, this allowed for real-time tracking of your information. You could see all this. And the same thing here, a BOLA breach. The flaw allowed any user logged into United States Postal Service.com to use an API to see account details for other users. And there was just no authorization on what I was allowed to see. So once I do a valid login, I take that same request, change the user ID information, and now I can see the details of another user. So super simple, not very difficult to pull off. I went a step further in this because what I think is funny here is this is how the old school assessments are done. And they're trying now to take APIs and fit them into the older security assessments that we're all familiar with. So the Inspector General's office said, hey, they found a number of authentication and encryption weaknesses in the service, meaning they were like, hey, you're not securing this in transit. Are you encrypting the data all the way? But they overlooked the problem, which was, the authentication and the authorization on the actual API wasn't tested. They didn't really even test for this level of an API attack, but was mostly concerned about how data was encrypted in transit. So what I'm getting at here, and this is something very important, is are you even including APIs in your security assessments? So when you do your, governance, risk, and compliance, are you including your API endpoints? And we'll get into, some of these other points. So we're just on A1. So when we get down into the A8, A9, A10, this question becomes very glaring. Do you know how many APIs you have? Did you run a security assessment on them? Do you do pen tests on them? So all that kind of stuff is super, super important we'll get into. But I love this here because you know that the people that created this application, before they published it and made it live, they were like, hey, we did the assessment here. We went through all of the assessments, all of the checkboxes on the security assessment, but none of them were focused on the API attacks. All right, A2. So A1 is A1 because it is probably the most damaging. You're going to lose the most data, but A2 is the most common. And so this is simply broken authentication on an API endpoint. So how are you doing authentication? How are you managing your tokens? How are you managing, token reuse, refresh tokens? All of that comes into play here. So are you, what's your expiration on your API tokens, and how are you securing those once they've been, initiated? And we see a lot of this, brute force credential stuffing attacks on just like you have a login web page form, you have an API login page. It's going to be the same thing. You're going to see the same type of attacks that you see here. 1 second, I'm going to bring up another. I got too many windows right now. Yes, okay, great. So some of the things that we are really around job manipulation. So there's plenty. If you do a search for job manipulation attacks, you'll see that nearly everywhere now. There's an article about this, either from changing the algorithm to modifying the claims inside your tokens to all of the important impossible travel use cases. So my token was just used. I used to log in California, and now 10 minutes later, it's being used to log in from Nigeria or China or someplace else like that. So impossible travel is what I refer to those as. And very key, very important that we cover those, that you monitor those keys. Lots of good options for that as far as like API gateways and things help manage that, and just make sure that you're watching, that you have eyes on how your tokens are being reused. Okay, so excessive data exposure. Now, I apologize for any API developers out there, because I feel that this one comes back to, I don't want to say lazy coding, but APIs give us the benefit of what I refer to as API reuse. That means I can create an API request, or I can create an API call that will return data. And maybe I have need for the data that is being returned by that API call in different parts of the application. Well, for me, instead of creating a new API endpoint, I'm just going to reuse the same API endpoint that I've used before. And this is what we refer to as excessive data exposure. So I'm going to give an example here, kind of like this, that I see quite frequently. So I create an endpoint that says get user information, and that's going to return the username, first, last name, phone number, maybe the address, maybe some account information, role information, whatever is contained on that user endpoint will be returned. But let's say I only need to display the first and last name and the email address to the user. Well, instead of creating an endpoint that only returns the first name, last name, email address, I'm going to create the application front end so it only shows those 3 values and not the address and the profile and everything else that is returned. What happens to that data that's being returned? Where does it go? It just sits in the request, meaning that if I capture the request, the return, the response, I can still see all that data. And that is at the heart what excessive data exposure is. And I'll give you an example here. So here we have an adult dating application that, like a lot of these, allows you to sync up with users in real time. Hey, we're at the same restaurant, we're at the same bar, and meet up. Well, what if I turn on private mode? I don't want any of that stuff to be displayed. Okay. Well, if we do that, what actually happens when I turn on private mode? It's not that there's another endpoint called private match users endpoint or something. It's not that there's another private endpoint that now only returns the data that should be displayed in private mode. No, it's just that it's hidden in the mobile app interface if the privacy flag is set. So the filtering is client side. It's done in the application, and the user thinks, hey, my privacy mode is set. None of this data is being displayed. And so once that happens, right, a real user is going to be able to match that user, see the data that's being displayed, and then do all kinds of funny things with it, like try and sync up with the person in the White House, right? Whatever it is. And so that's a classic example there of excessive data exposure. And this really comes down to one, the benefit, so the ability for APIs to, you can create one API endpoint and then use that in different applications and different parts of the application over again. But then you have to make sure you're not doing something like this, where you're returning data that shouldn't be displayed. Okay, excellent, wonderful. All right, so let's move on here, resources and rate limiting. So the resources and rate limiting here is really different from what we've seen before, meaning that when I think of resources and rate limiting, I think of maybe like a DDoS attack, somebody sending more attempts, more requests than a server can handle, and trying to slow down the application or even bring it to its knees, right, to crash the app. In the API world, it's even less than that. Don't think of a distributed denial of service, but now I'm trying to just deny the service or to bring down the smaller microservice of the application. So when I look at customers here, and when I look at what I'm trying to, when I speak with my customers here around this specific one, I'm looking for endpoints that will have some type of page associated with them, a filtering limit, a limit size, max return. Any one of these will be useful to attempt this style of an attack. And what we're saying here is we just want to increase these numbers to where they're arbitrarily large and the microservice cannot respond with all the data that's going to be returned. And if there's no input validation on what's expected, you can either walk away with all of the data in a single API call, or you can create a denial of service where now you're going to get gateway timeouts, or the service just won't respond, and you're going to get 500 errors perhaps, where then you'll see server misconfiguration errors and things like that. So great, a great endpoint to launch an attack on. Search endpoint, like endpoints that do searching, are very common because that's where you're going to get into the paging when you try and return multiple values. So definitely take a note on these, and don't be confused here that this is some type of a network rule or a network limit. Obviously, we see different things here as opposed to what you might be familiar with on a firewall setting, doing rate limiting there. Excellent. Okay, so what we see here with this, this was when they came out November 17th on Bumble API, which I think just went public maybe like a couple weeks ago, no, 1 or 2 weeks ago, or maybe they're gonna go public. But another dating application. I don't know why these things always seem to be the most, the most difficult here. But this was simply a case where there was unlimited additional filters, meaning I could increase the basically the filtering limit to 2 million, however many I wanted to, and then I could return the actual user IDs. So it would just return as many users as I wanted to. There was no paging or limiting. I could just set it however I wanted to. This really comes down to input validation, to how you want to make sure that you have limits set so the server just isn't returning all of this as much as you want. Maybe you let the user go from like 1 to 10 pages, but they can't return 1,000 pages of data at once. All right, great. So broken function level authorization. So this is where now we're saying, okay, I see that I'm supposed to send a post to this endpoint. Simply stated, what if I turn this to a delete? What happens if I turn this to a delete method? What's going to happen? Am I now going to be able to remove data? If it's only accepting a post, what happens if I send a put? Lots of times when I run this style of an attack, what I'm hoping for is some sort of server misconfiguration. I'm going to cause a 500 server error and return something that gives me some type of insight into what the application is running. Maybe I can see it's a Spring framework. Maybe I can see if it is a Jackson XML. And then that'll let me try additional attacks based on maybe some CVEs that are tied to those frameworks. And that's really what I'm hoping here. Occasionally, I did have one instance where, the post endpoint was secured, but I could send a put, and then I knew I was bypassing some of their internal security checks. So you can see some of that where then maybe on the post framework I can't, but if I go put, then maybe that will take an additional attack or something like that I could send. Um, so don't forget to check those, and you definitely don't want to just have open methods to your APIs. Know what methods you're expecting, and then deny all the rest. Excellent. So this was a case here on New Relic where kind of the exact thing happened. There was a get, but if he sent things to the post endpoint, then he was able to get privilege escalation. Um, and it's just, you have a get and you have a post. You try both of them to the exact same endpoint, and then one gets you some permissions, gets you above what you thought you could. So same thing here. Just make sure that you're looking at those, and you're monitoring both endpoints and not missing what you have going on there. All right, mass assignment. So it was asked that I focus a bit on A6. So we'll look at some of these. I actually think I have a pretty slick example of one that was I recently discovered in the customer environment I was working in. So mass assignment is now I'm trying to elevate my permissions. This is normally done, let's say you have a login endpoint. What happens if I add is admin true to that request? What happens if I have just my user profile endpoint and I add, SSO admin or role admin, whatever it is, all of these can be attempted and see if the system takes it. And now my permissions are elevated. Now, mass assignment can be a little misleading in most of the articles that I've seen published. Mass assignment is associated strictly with permissions. So trying to assume elevated permissions to gain access to deeper parts of the application. But mass assignment is really about just inserting excess parameters to a request, to a legitimate request. There's nothing malicious. It's the same endpoint. It's the exact same request. I've just basically modified the body slightly to include additional parameters. And at the heart of it, that's what it is. You're adding additional parameters to the API call, which may not be originally defined in the request. And so you can literally try a mass assignment almost on almost any request. On any request, you can attempt to add additional parameters. So let's take a look at one of the examples here that I had, which was interesting here. So here we have a request to register, a new user registration endpoint. It asks for the email. And so I type in my email, I hit enter, and in the response, and what's going to happen here is the application is going to send me an email, we all get them, to this email address to register me, to complete my registration, to basically activate my account. Well, in the response that I get from this registration email, I can see here that it responds back with email verified as false. Now, this is also basically an example of excessive data exposure. There's no reason for the registration endpoint to respond and tell me that the email has not been verified yet. But when I saw that, I was thinking to myself, okay, so it's not verified. What happens if in the request, I just include that parameter, email verified equals true? So I go in, I create another email, and this time though, I modify the request to tell it that it's true. And now when I got the response back, you can see it included the updated attribute here that now the email is verified. And sure enough, I didn't have to go in and click or select any type of link that was sent to that email address, and I now could enter the system as a verified user. So a couple of things here happened, right? We had an A3, no need to tell me if my email's been verified yet. And then it gave me the exact format that I needed to include then in the mass assignment to up my privileges and become a verified user. And again here, right, and the first 6 that we see here are easily, unique to APIs. There's no traditional application security solution that would look at this and say that there's anything malicious here. It's a legitimate request. There's nothing here that would say, hey, that's an attack, or this person just got in without verifying his email. So let me see here. There's a good question came in here, Scott. Let me read through this one. Are there certain classes that are easier? Right. So what can be done? What are easier here? So um, so I'll definitely highlight here. There are a few vendor-based solutions that will detect these types of attacks. Most of the time, the API gateways are going to help you on A2, so broken authentication, because they can manage the API tokens and things for you. And then from a developer perspective, really all of these kind of come back to, secure coding, doing these types of checks in a shift left scenario before the application gets published. But I find that is, the whole shift left conversation is nearly impossible to rely on. So you have to have some type of a, API security based solution that can look at this in real time as the traffic or as the requests are coming in. And so there are solutions out there. I'd be happy to speak on that maybe individually or something. But I say right now, the API gateways are great for, like I said, the A2 and for publishing APIs, but they're not going to match up for really like the A1 or 3, 4, 5, 6 that we've highlighted here. Hopefully that answers your question, Scott, but if not, sure, we can dive in deeper as well. Okay, great. But yeah, so just to highlight one more time, before I get into the last three here, is I want to make sure that we highlight the difference between what was the attacks that we've seen in the past and now how APIs fall into this, and how the API architecture itself has changed the attacks that we now see. And this is why, for me, when I work with my customers, when I work with security assessment companies and pen test companies, that you are including APIs in those assessments, and that businesses now have to include those as part of their audits, because if not, these types of attacks just continue to proliferate, if I said that right. Okay, so security misconfiguration. We've kind of seen this before. This isn't necessarily anything new, but simply this is kind of what, for me, when I come in and I am attacking APIs, before I get super focused on endpoints, I can just send, a burp scan, and this is kind of what I'm looking for. If I can send just malformed data, if I see a field that is expecting a telephone number and I send in there a super long sentence, what's going to happen? Is the system going to catch that? Or is it going to do something like this and puke on itself and expose to me what the underlying architecture is? Meaning, is it a Spring framework? Is this Jackson XML? Those are some of the ones, obviously I see a lot. Is it, what was one, Curdle, or there's another one out there that I see kind of frequently. But if those things are exposed, what I'm going to do is I'm going to then say, oh, okay, great. Here, I'm going to take this TIBCO and I'm going to see what TIBCO CVEs there are. And then those are the next things that I'm going to start attacking with on this endpoint, because now I know what it's running and what the architecture is. And this happens a lot with just simple input validation, where you're not catching, and validating the state of the data that comes in. And so it's an A7 because it's not like you're going to walk out the front door with the data right now, but this is such a good stepping stone. If I can find one of these, then usually I have enough information to spend the next hour or 2 hours, hitting this specific endpoint. So make sure you're catching this stuff and not letting this stuff leak out. The next one here is injection. And this is where we get into now more of what we're familiar with, right? The standard 1=1, select star. The NoSQL style injections now we see a lot more on API endpoints, because they expect that maybe that's what holds some of this data in the application itself. But these are a lot further down on the list. To be honest, if this type of a request makes it to your actual API backend, then you're probably 15 years behind the ball now, because you should already have something that detects this and protects your environment from these styles of attacks. I refer to these as, traditional now, or, like I speak with the traditional applications, because from an industry perspective, we've been protecting and detecting injection attacks for probably almost 20 years now. For me, when I work in the API security solutions that are available, I don't even expect for those solutions to see this kind of traffic, because it should be stopped now way in front at your front door. Okay, so improper asset management. So the last two here, the A9, so improper asset management, and A10 insufficient logging and monitoring, I would say are the two biggest issues right now in API security. So outside of the threats, it's the fact that most businesses don't even have an idea of how many APIs they have. And so I'm going to pause here. I'm going to ask a question to the audience. If you can raise your hand. If I were to ask you how many APIs you have in your business, could you, give me an answer, give me a close answer within, say, 10 APIs? Raise your hand if you think you have that answer. Oh, I see a couple X's. I see a smiley face. Yeah. Okay. 2. Yeah. All right. Not bad. Somebody's passing the buck there, it looks like. Well, look, I'll say this, and this is easily the black hole right now. And if you don't have that answer, it's expected. It is absolutely expected. And is why from an API security, as security professionals, as developers, we have to do a couple things. One, if you're not using Swagger files or open API specification files to document your APIs, you need to start. And maybe I should ask that. Um, do you create API documentation files? From one of my developer friends out there, if you raise your hand, are you doing that? Yeah, some people thumbs up. So great. So please do that. That's where you start with improper asset management, is get your documentation right. And once that happens, then the tricky part comes, is where you have to inform the security team about the API documentation. So that's kind of where we're going there. I like what Aaron said here, is I could get it within 10x, because what I have found, if a customer tells me that they have 50 APIs, or if they have 100 APIs, it really means they have 10x whatever number they give me. I had a customer, recently tell me that they had roughly 50 APIs, and when all was said and done, they actually had 950 APIs. And it speaks to the easiness of API creation, proliferation, how fast APIs are created. And then it just speaks to the fact that security teams haven't been looking at APIs as a source, or as something that needs to be underneath their purview. And as we've seen with the attacks, we need to be involved in that conversation, and we need to have that. Let me look at some of the questions here that came in. I appreciate the feedback, guys. Yep. Yes. So if you do use Swagger or other types of documentation, make sure to protect those endpoints so you don't end up in the A3 bucket. And that is true. Great point there. Great point. Okay, great. Yes. So these examples are specifically geared toward REST APIs. So GraphQL APIs do have different attack interfaces and different attack methods. So protecting the schema is often the most important. Making the schema publicly available, I've seen backfire. So usually in a lot of the security for GraphQL APIs, it is protecting that schema, because once somebody knows the GraphQL schema, then they're kind of open to attacking that directly. APIs don't have often as much of the vulnerabilities that we see on the rest, because it can be a single GraphQL endpoint within maybe 400 or 500, parameters that can be randomly or just, called from the application. So you don't have to really know how many, the GraphQL can have one API endpoint, but then from that endpoint, you could have 800 different variations, right, of the query. But what I will say with GraphQL is, don't assume then that your data is still secure. So what you really need to do is be able to identify what sensitive data is being accessed by my APIs. So, I mean, we're talking a lot here on A9 because this is where it comes in at here. Not only do you have to know which endpoints you have, but which endpoints are accessing which APIs. And I'm sorry, which endpoints are accessing sensitive data. And that's just as important as knowing the endpoints. The other thing, usually when people use GraphQL, they're also using gRPC to transport that, or as the transport layer, and not using like layer 7 or HTTP methods. Though I do see lots of people that are doing GraphQL without gRPC, but usually that's the same as well. So we could have a whole different session on GraphQL, which makes me think that might be my next topic that we can talk about. So great. Okay, really good question here from Scott again. So are you counting internally written ones and vendor provided ones that allow access to your data in a SaaS or PaaS solution? So very good. When I work with my customers, we don't differentiate between, an API that I'm publishing or an API that I'm consuming. If I'm publishing an API, it's usually so my customers can interact with my business. If I'm consuming an API, it's usually because I need data from that API provider. Or maybe it's not, maybe it's an API that I am sending data to, but I'm sending it to a third party. Or maybe it's not a public API, it's a private API, but it's still accessing data that I'm holding. This is why it doesn't matter about the API, it matters about the data the API is accessing. So if I am the one that is either holding the, so if I am holding, somebody likes to draw on my screen, if I am holding the sensitive data, it doesn't matter how it's being accessed or how I'm making it available, it's just being accessed. That makes sense? And I think that's an important thing here. So make sure that you understand, if I have sensitive data, PII, identifiable information, being accessed by those APIs, then it needs to be underneath my purview, regardless if it's public, private, east, west, north, south facing style traffic. Okay, great, excellent. I'm gonna move on here to A10. I can see I've been going, almost an hour here, so I don't want to take too much time. This is one thing here, though, that is important. And when we talk about API documentation, as opposed to what I have live, what is being published, you want to be able to, when you look at, doing your API security programs, when you look at doing, turning to something to give you access here, I think I can get rid of annotations, right? Clear. There we go, right? Great. So one thing here is you want to be able to have a solution that, one, identifies what is being published in your environment. What APIs do I have running in my environment, either public, private, whatever direction they're flowing, and then be able to compare that to my documentation. The reason is because it's going to highlight APIs that shouldn't be published. This is a big thing here when we talk about improper asset management, is the whole shadow or rogue API proliferation, all of that. So you're going to have shadow APIs that you didn't know were accessing sensitive data. You're going to have rogue APIs that should have been deleted. You're on version 5 and this is a version 1 API endpoint. It shouldn't be live anymore. And that is what API discovery does. And that's how you monitor. And that's how you get rid of this A9 and close this loop. So if you don't have API discovery in your environment today, this is where the whole 10x number comes from that I used, and that Aaron used. is that you may think you have 50. When you do an API discovery project, you're going to have 10x that number. Never fails. So the next thing then, insufficient logging and monitoring. And this just speaks to the lack of visibility that businesses have into your API environment. It's not that the developers did anything wrong, right? They're moving at the pace of business. They're creating the APIs, they're modernizing the infrastructure most of the time. I mean, I don't like to use it, but the digital transformation of businesses, that's what APIs is doing, right? It's modernizing the application infrastructure. But if there's no communication, if there's no insight provided back to the security team, if the security team doesn't have any insight into the sensitive data now that the APIs are giving access to or are sending, transmitting, then you fall into the A10. So it's interesting how the A10, the top 10 here is listed, right? We go from the most critical when we talk about data exfiltration in a breach scenario, but really, if you're not doing A9 or A10, you could already be breached, right? You could already be having people walk out the front door with your data. And because there's no monitoring of the APIs, you're never going to know. And so that's why when, again, I've said this a couple times, I make my customers keep these APIs in those governance assessments. You have to be auditing those, you have to be doing your pen tests against those, and not just be focusing on the traditional applications. Great guys. So that's my soapbox. That's my advice. I really hope it was helpful. Appreciated the comments there, the conversations. We do have a few kind of questions here at the end, and then we are gonna do a raffle at this. So we have a number of gift cards that we'll be giving away. We're gonna be doing this via email. So I will have the emails for those that have registered, and Travis will, and he'll be sending out a few gift cards to those emails here. But okay, great. So first question, number one, API traffic currently represents what percentage of all internet traffic? And this is from an Akamai report that came out, I think 2019, but was it 2020, October 2020? That was longer than that. All right, looks like we get a few people here. Okay, very good. Maybe next time I'll do a poll here with Zoom. We'll see. Okay, question number 2. Gartner predicts API abuses will become the most frequent attack vector, resulting in data breaches for enterprise web apps by which year? Okay. Nice, guys. Everybody picking up on what other people are putting down. Not bad. Okay, question number 3. Comparing the OWASP API top 10 threats versus the original API Sec top 10, what percentage of attacks are unique to APIs? Yeah, what percentage of attacks are unique to APIs? Ah, okay. All right. We'll get the answers here coming up. Question number 4. He was here in the very beginning. How many parameters were required to be changed by an attacker to expose 2 million Verizon payment records? And I did make sure to say that out loud, so hopefully you were listening. All right, maybe next time I'll whisper it if everybody gets it right. Well done, guys. Well done. Thanks for being here throughout the whole presentation. I know it's tough listening to a guy talk the whole time for an hour, but appreciate it. So here we go. So number one, I saw a lot of D's. Very good. Question two, I saw a lot of A's. Looked really good. So 2022. So we're about a year away from having the internet break and having APIs burnt to the ground. Question number three was maybe a trick one. Maybe the wording was off. But what we're doing here is that the top 10 threats versus the original, we have 70% are unique to APIs on the API top 10. And question number four, how many parameter changes were required? So this is D for one. All right, and glad you guys picked up on that. And we've said this a lot, I think, during the top 10 here, during this conversation. We were able to highlight some of the things that were specifically unique to the top 10 to APIs and why really today we see current solutions, the current security vendor landscape is catching up to APIs still. So one more slide here. I just want to highlight three things that I would consider to be important when you're looking to secure APIs. One is discovery, and this is what we talked about with A9 and A10. You need to have something that will discover your APIs in your environment. When an API environment changes as much as I know your API environments do, you got to have something that will discover those APIs. Next, prevent the threats that we talked about. So securing against the API top 10. And then remediation. So this would be like your security misconfiguration. This would be like A3, where you have endpoints that are exposing an excessive amount of sensitive data in any type of shift left style capabilities. So, doing some of your OAS file comparisons, securing your API documentation, providing that feedback before you push out an API. So those are the key capabilities that I would focus on when you're looking for an API security solution, or if you're ever in that space. So guys, really appreciate again your time. This meeting was recorded, will be made available. And before we wrap up, any last questions or any other topics that you'd like for me to hint on? I'm fine to take you guys off mute here, and we can stop the recording here. Let me do that. Stop recording.